4 for you, but add another one for another formula to get that to do it easier. Okay, they are the same, I mean denominator, totally different, multi to each other. What I mean by totally, what's the same, what's the multi? When I say the same, the denominator are like each other. For example, A, B, C, C. Okay. So in that case, you just do it easy. How? Just say is equal to A plus B over C. Example number 1 for you. Okay. I have 1 over 2 plus 5 over 2. So directly say is equal to 6 over 2. Why? Because we have the same denominator. That's a CC. Example number 2. X minus 2 over 2 plus X over 2. So I say what? I say the result is equal to X minus 2 plus X over 2. Okay. So how about if I say, if I have some more example, if I say 2 over x minus 1 over x. So also I have, this one plus. Also I have what? Fraction number 1, addition fraction number 2. So how we deal with this one? That's it. You have a same denominator. So I say is equal to 2 plus x minus 1. And later you can simplify this one, okay? This is just for dealing with the two fractions if we have addition or subtraction. So we got the multiplication in the first rule. In the second, we got the division. Now I'm going to talk about third and fourth rule in your page 4, number 4. So how we deal with the third and fourth, if in case we have same or totally or multi denominator. When I say totally different, I mean that I have A over C plus B over D. So the C and D, they are totally different. So how we deal with this one? How we solve this one? I will give you an example. Example number 1. 1 over 2 plus 5 over 3. So we have two fractions. We have addition, but the denominator are what? Are totally different. So how we deal with this one? We have a lot of methods for this one. I'll give you the standard one you can find in the YouTube or any other books. Many different kinds. Maybe this rule is this way is simpler for you, maybe it's complicated for you. So try to find your way. So I'm giving you the standard way. So I say we multiply these to each other, so 2 by 3, and we say we cross multiplication to the numerator with the second denominator, also first numerator with the second denominator. How? So we multiply the denominator. So I say 1 by 3 addition, we have addition, so 2 by 5. So first of all, I'm repeating it for you. We have 1 over 2 plus 5 over 3. I say first of all multiply these together. So I get what? 2 by 3. Now then multiply this one by that one. So 1 multiply 3. Then we have addition. Then again later multiply this one by that one. 2 by 5. So I get what? I get maybe 6, 3, 10, and go on. Okay, dear? So the important thing is the way that you want it. That's all. This is the standard way. We have a lot of methods. You can use one of them. It's okay for me. For me, it's okay. how can you just do the logic way, use the logic method? It's okay for me. Example number 2, in case we have x, so I have x minus 2 over 2 plus, or let me minus x over 5. Now I have first fraction, second fraction, denominator are not equal, so this is the case number 1. No, this is the case number 2. Case number 2. Why? Because they are totally different. 2 and 5, there is no relation between them. So I directly say 2 by 5. Okay, now this one by that one, so x minus 2 multiply 5. We have what? We have subtraction. Here's the subtraction, and 2 by x. And we will solve this expression later, but here's just I'm giving you the methods. Now case number 3 is a multi. Okay, so what do you mean by multi? I mean if I have the fraction like that, see, maybe by example number 1, if I have a, oh sorry, let me give you more example about the second case, then I'm going to the third one, so accept my apology. So if I have 2 x minus 1, let this one be x plus 2. Now look, I have 2 fraction and there's addition between them, and it's not case number 1, they are not the same denominator, so they are totally different. So how we deal with this one? It's easy, denominator by denominator. So now 2 by this one, okay, addition x by x minus 1. Okay dear, so they are not different, they are easy. If you first you solve this one, then you try to that one, and if I give you any example, just follow the rule and you can solve it. Now I'm going to the case number 3. So I said they are totally different, or multi. What do you mean by multi? By multi I mean, for example, I have 1 over 2 plus 5 over 4. Now you can deal with this one as the second case. You can say they are the second case. Why? Because they are totally different. Now you can solve this one as a case number 2. So okay, this one for you. Okay, but this methods or dealing with this one with the second case is easy for number, but it's not easy for the expression case. When I say it's easy for number, I mean if you have something like that. When I say it's not easy for the expression, mathematics expression, I mean something like that. How? For example, first of all, let me solve this one for you, or show you how what I mean by multi. Then later I will clarify my objects for you. You know, there's a relation between 2 and 4. I can write down like this. Am I right? You know, between 3 and 9, 3 and 27, 2 and 4, 2 and 8, 2 and 16. There's a multiplication between them. So in that case, if you find, or if you can distinguish between the case number 1 and 2, and you can recognize the case number 3, just say, I'll change it to the 4, say we will choose or select the biggest or the largest denominator. Okay, which of them? Between 2 and 4, which of them is the largest one? Surely number 4. Okay, and put the largest fraction as you have. Now I have without any change. So I select number 4, and I put the these fractions that they contain or that they had the largest denominator here and multiply some numbers to the other fraction. So I should multiply which number by 2 to get 4? Surely 2. So 2 by 2 is equal to 4, and multiply 2 to here. So I say 2 by 1. Now I get what? I get 7 over 4. I'll repeat it again for you. I know it's not easy. For another example, by another example. Okay, now I'm just dealing with the numbers, not the mathematics expression. So in case I have one, or let's say 3, no, 3 is not nice. 4 over 27. Okay, multiple on addition, subtraction, anything. 3, here's be 5. So you have two fractions and there is a subtraction between them. Okay, so how about these denominators? Is there the case number and they are the same? No. Is there the case number 2? Yes. Is there the case number 3? Also yes. Why? Because I know 3 to the power 3 is equal to what? Is equal to 27. So we will select the largest or the biggest, what? The biggest fraction without changing anything, and we have subtraction here. Later I will choose the number that I can multiply by 3. I get 27. So it's what? Is 9. 9 by 3 is equal to 27. You know. So also I will multiply 9 by 5. That's all. Okay, dear? That's all that we have in here. So how about mathematics expression? If you have x over 5 minus x minus 1 over 25, I'll directly say it's a case number 3 because there's a relation between them. So I'll choose the number 5, the largest one here, and I'll multiply which number by 5 to get 25. Surely it's 5. So I say directly 5 by x. Okay, another example. Example number 4. If I have 2 or 2x minus 1, look, change it. It's a harder, it's a complicated one, really. X minus 1 square by 2x. Look, this number will be 3, okay? Because really I'm doing or finding this example in my mind. That's why sometimes I'll change the numbers. Sorry for all those erasing. So we have two fractions, f1, f2, and there's a subtraction. So I need a common denominator. We need a common denominator. As we mentioned here, we need common denominator. Jerry Habash. So how you find this common denominator? If it's a case number, it's easy. Case number 2, you should multiply and cross. If it's a case number 3, why I know it's the case number 3? Because I have x minus 1 and x minus 1 squared. So they are the same. They are the relation between them. So with the power 1, this is a power 2. So we choose the largest or the biggest exponent. Now I should multiply which things here? Now the box. I should multiply which to get x minus 1 square. So surely the same. I should multiply by the same things. So that's why x minus y multiply by x minus y, I will get what? Surely I get x minus 1 square. That's why I say x minus 1 multiply by 3 to the numerator. I'll do this one again for you. We have 3x minus 1 minus 2x x minus 1 square. So directly I say I'll choose the biggest one because I know it's a power 2. Now I should multiply which number, which things, which object, which expression to the x minus 1, forgetting what? Forgetting the common denominator. Surely it should be by itself. So x minus 1 multiply x minus 1, I will get this. So directly say 3 by x minus 1. That's all that you need to get the idea about the multiplication and common denominator. Okay, so the same denominator or the different denominators, okay,